All right, Finite Math class. This is the second part of the first packet of notes that I gave you. So we're starting off with Venn diagrams. I believe this should be 2.3. I wrote 2.2 by mistake. So the whole box that we have in our Venn diagrams is going to represent the universe. We'll call that U. That's all possible elements that can be used in your diagram. The circle A represents the elements that are in set A. Circle B represents the elements that are in set B. And then the shaded region, let me say it right. The shaded region represent all the elements that A and B have in common. All right, so a simple example here, we have 1 through 10. Those are the numbers that are in our universe. In set A or circle A, we have 1 through 5. In circle B, 2, 4, 6, 8, 10. And so 2 and 4 are what they have in common. Whenever you're doing Venn diagrams, it's always best to start with what they have in common. Start with what's in the middle. So 2 and 4, we put those right there in the middle, that common region. And then from there, 1, 3, and 5 are the elements that are in only A. So that's why they're sitting on the outside here. 6, 8, 10 are in only B. So they're sitting out here. And then notice if you go back and check in your universe, 7 and 9 were not used. So they're sitting on the outside. Complement. The complement of a set will be all the elements that are in the universe that are not in that set. So the complement of set A would be all the elements not in set A, but are in the universe. So we'll use this like apostrophe to represent the complement in your book. So remember set A was 1 through 5. So that means when we compare set A to the universe, the elements that are not in set A are 6 through 10. So the complement of set A would be 6 through 10. All right, so your intersection would be all the elements that are in A and B, the ones that they have in common, and we'll use this upside down U to represent the intersection of A and B, and we already talked about how that was 2 and 4. The union of A and B would be the combination of all elements in both sets. So we will use the U for the union of set A and B. It's not actually a U, it just looks more like a U than it does any other letter, so I call it a U. But it's the reversal or the upside down intersection symbol. And so when we union A and B together, you get 1, 2, 3, 4, 5, 6, 8, and 10. The empty set, whenever you intersect or you want to know the intersection of a set and the empty set, in other words, you're asking what does a set and the empty set have in common? The answer is nothing, so it will be the empty set. And then if you union the empty set with a set, if you union nothing with set A, then all you will have is set A. So that's all that they're saying here. So just another example, if I had the universe of 1 through 7, A is 1, 3, 5, 7, B is 1, 2, 3, C is 2, 3, 4, 5, 6, and I want to know the intersection. What does B and C have in common? I see it would just be 2 and 3. Here I have the complement of A, union the complement of C. So the first thing you want to do is find out what is the complement of A, then find the complement of C. So the complement of A is 2, 4, 6. Complement of C is 1 and 7. Then you union them together. So it would be 1, 2, 4, 6, 7. Here we have the intersection of A and B and then the complement of that. So just like with order of operations, you do what's inside of the parentheses first. So you look at A and B and say, what do they have in common? You go back to A and B, it's just 1 and 3. And then you want the complement of 1 and 3. So everything that's not 1 and 3, but is in the universe. So you look at the universe, 1 and 3 is here. We don't need 1 and 3, but we need the 2, 4, 5, 6, and 7. And so that's why we have this answer here. And then for this one right here, we have the complement of B intersect A. Find the complement of B first, which is 4, 5, 6, 7. Look at what A is, 1, 3, 5, 7, and ask what do they have in common. That's just 5 and 7. This 70%, 30% was something I was discussing with a previous class about their percentage on their test and homework, so that has nothing to do with the problem. All right, so this is another part of 2.3, the cardinal number of the union of two sets. So you want to know the cardinal number of the number of elements of the union of A and B. You would take the number of elements in A, add it to the number of elements in B, and then subtract what they have in common. Then under here, I was just letting you know that union and or represent the same thing. Intersection and represent the same thing. So another example, or just applying an example to what we just talked about, the universe 1 through 10. A, we have 1 through 6, so the cardinal number of A is 6. B, 3, 5, 7, 9, the cardinal number of B is going to be 4. So if you look at what we're trying to find, we want to find the number of elements in the union of A and B. If we just add them together, we notice we have 10 elements. But notice if we were to look at them, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but 3 and 5 are counted twice. So that's why we have to subtract what they have in common so that we don't count those numbers twice. So we do 6 and 4, and then we subtract 2 because we have 2 elements that were in common. So it's actually 8 elements that represent the union of A and B. And we see that right here, 1, 2, 3, 4, 5, 6, 7, 8 elements. And that's because 3 and 5 we're not writing twice. Here we have a mini word problem that emphasizes the same thing we just did in the previous slide. Some results of the campus blood drive indicated that 490 students were willing to donate blood, 340 were willing to serve breakfast, and 120 were willing to donate and serve. How many were willing to donate or serve? So don't forget what I mentioned about and or. And represents intersection, or represents union. So we call D donate, serve for S. The number of donators was 490. The number of servers, 340. The number of donators and servers is 120. So if I want to know the number of donators or servers, I will add the number of donators, number of servers, and subtract what they had in common, and I will get the 17. So Venn diagram with 3 sets. If I was doing this on the board, I would erase all this and wouldn't have any of the slashes. So we have set A is A, B, E, G, H, I, J. Set B is B, E, G, H, L. Set C is A, C, E, H. And then the universe is A through L. And so what we would do here is start with what they have in common. Remember I told you, you always start in the very middle to see what they have in common with all 3 in this case. And it's EH, so we start there. And EH wouldn't be anywhere else but in this middle. And then you can start from your inner pieces and work your way out. So now you look and say, what does just A and B have in common? It would be B and G. What does B and C have in common? It wouldn't be anything. And then what does A and C have in common? It's just lowercase a. Then in this part is what just A has in this circle. Over here, L is what is just in B. And then here, C is what's just in C. Once you've filled out all of your circles, then you check your universe and see what has not been used. And that's why I did all the slashing out. So it will let me know what's left. And D, F, and K are what's sitting on the outside of your circles. And you can place them anywhere on the outside of your circles. All right, another example. 1 through 9 is our universe. 1 through 5 is A. 1, 2, 3, 6, 8 is B. 2, 3, 4, 6, 7 is C. Start off with what A, B, and C have in common. That's 2 and 3. A and B, just A and B would just be 1. Just B and C would be 6. Just A and C would be 4. Only in A would be the number 5. Only in B would be the number 8. Only in C would be the number 7. And then what's not used in the universe would be the 9. And that's sitting on the outside of the circle. All right. So here, taking those same setups from the last slide. If you want to know what this would be, the first thing we do is hit our parentheses first. What does B and C have in common? That's 2, 3, 6. Then you union that with A. And so that'll be 1, 2, 3, 4, 5, 6. Then we're looking at the union of A and B, the union of A and C, and then what do they have in common? So we did that down here. We union A and B, union A and C, and what they have in common was 1, 2, 3, 4, 5, 6. All right. And so this next one, we have A, and then we want to know the intersection of what does A have in common with B union the complement of C. So the first thing that you could find or would find is the complement of C, which is 1, 5, 8, 9. Then you union that with B, which is 1, 2, 3, 5, 6, 8, 9. Then you look and say, okay, what does A have in common with 1, 2, 3, 5, 6, 8, 9? And it'd be 1, 2, 3, 5. Okay, one more. So we have A union C, union A and C together. That'll be 1, 2, 3, 4, 5, 6, 7. Then you compare that to the universe and say, what's the complement of that? What's not here? And that's just 8 and 9. Then you ask yourself, what does that have in common with B? B is 1, 2, 3, 6, 8. So the only thing that B has in common with 8 and 9 is the number 8. All right, so we'll stop right here with that slide or that lecture, and we'll come back for part 3.